Welcome back to Murph Codes Python. We are continuing our Python tutorial and building our CRUDdy Buddy app. For those of you who are not sure what the heck CRUDdy Buddy is, it's a file record editor thing. With this app, we're learning file manipulation, not just how to create the files, how to delete the files, but how to write to the files and how to read from them. And in the process, we're also learning about variables and math operators, input-output, conditions, loops, functions. We haven't quite got to objects, nor have we covered fully import statements. We've used them to import pre-written libraries such as the OS module and the sys module. We've kind of covered documentation a little bit. And we have not yet gotten to graphic user interfaces, but we will soon, I promise. I'm not going to leave y'all stranded with just learning how to write for the command line, because none of you are going to do that. Nobody is. Nobody's going to want to. It's boring. The command line intimidates everybody. What they need is a nice, safe window with buttons and entry boxes, and we're going to show you how to do that. I don't know if we're going to do that in this session, but I will get to that. Where we left off, we have our program here. It's mostly functional. Oh, by the way, look at that. Y'all can see my mouse now. Whee! Yeah, I finally found where that option was hidden. So, hopefully you'll have an easier time following along when I point to stuff and say, oh, right here, we're going to do things. And, you know, you're not, like, right where. Your mouse is invisible, dude. Alright, so, I've actually been working on this code offline on a couple of different devices here. So, you'll just have to give me a minute while I attempt to update some of this stuff before your very eyes. Okay. Now, one of the things I said I wanted to do was I wanted to create a little more of a little more help documentation. So that you can see a bit better what we're doing here. Alright. So, I'm using a standard kind of a format of my own design, my own choosing, on these documentation strings. I state very simply what it does. I give a use case example. And then down here I have a, immediately below that I have a sort of a key for what all the various variable names are supposed to be indicative of. So that someone who's, you know, running help create file will know what the heck they're supposed to be doing with that and what each of these arguments is for. Now, I want to do this with all of them. Like I said, I have this written up on a different device here, so I'm just copying all of this over because I've already written this out When did cap locks get triggered? I'm also going to put a blank line between the document string and the actual code for the function. I'm going to put 2 blank lines between each of my functions here so that it's a little easier to read. It's not necessary, but it's, you know, I feel like it's better than not doing it. I'm also going to copy those because pretty much every one of our files here is going to have that. Now, some of you might have caught on, I'm just literally copying the, this bit right here for the use case in most of these cases. The only difference is like right here, where we have a return and it's going to spit out some data. I want to indicate to the user that this function should probably be assigned to a variable so that they can use the output. Otherwise, if there is no return statement within the function definition, it doesn't need to be assigned to a variable. There'd be no point in assigning it to a variable because that information, it doesn't spit out any information. It's not going to tell us anything. There's, you know, there's no data output. It just writes to the file like this one. Like, you know, our return statement is basically this. But it's happening all within the function, so we don't have to worry about it there. Alright, what did I have for my documentation here? Hold on here. Ah, there we go. Sorry, I lost my place for a second. Like I said, I'm having to write this from one of my other devices. Now, in some of these, our documentation is longer than the actual function itself, and that's normal. In a lot of programming, you're going to find that the information we're giving to users is far, far more than the actual lines themselves. But this is human readable. This is what the computer does. And if users are just going to be using this little line, it's best that they know what it does, have a complete sort of manual for it, so they don't have to worry about, what's it doing? What's it going to do? How do I use it? They can just know it works. They don't have to know how the internals work. They can just read this and go, oh, well, it does that. Okay. Simple. Alright, so we want to make sure we're giving them all the information we can. All the information that's going to be relevant to them, that is. Wait, I have that. There we go. So yeah, like this is a single line. Did we honestly need to write a function for it? Not really. I mean, most programmers are going to know how to do os.remove. We're not really saving them any work here, but we created it as part of our tool set here for creating files, reading files, updating files, deleting files. That's where we get CRUD. C-R-U-D. And once again, we're doing C-R-U-D. Now, when it comes to the records, though, we got a little bit of we got some missing code here, as you can see. Because they all still say pass. Don't worry. I do have those finished for us as well. And as I get to typing those out, I'll explain what they do. to change this. There we go. Okay. I felt record data was a bit more readable, a bit more user-friendly. New data could be anything. We specifically want people to know that's the record information that's being written to the file. And we're trying to make it as obvious as possible, because even though we're creating this very extensive doc string for the help file, if we can make it even more obvious what it does and what it's for, that's even better. That got a bit wordy. All right. Now, our create record really just takes advantage of our read and write file definitions that we already created. It takes that output from the read file, appends the record data. However, I'll make some changes here, because one thing we did is we're changing what record data is. Record data is now a list of data fields that make up the record. So, since that's going to be a list, we got to turn it into a string. And the way we do that is we take our data delimiter, put some quotes around it, and we run the join method. Said method. Same thing as a function, but it is part of an object. A function that's part of an object is referred to as a method of that object. Everything in Python is technically an object. You'll find that's true in a lot of programming languages. So strings have various methods you can use. This string, we're accessing the join method. We're passing it this whole thing will spit out a string. To the end of that, we're going to tack on our new line character, and we're going to append that to our file. See, that's what the append is. That's also a method of our list object. So you've been working with objects this whole time. You just didn't know it. And don't get confused or scared or worry about, what all that means, because we're going to get into objects here as soon as I get this file updated with all of the changes here. And there's a lot of them. Like I said, I wanted to flesh this out off stream, but I did so on my mobile device using using that QPython 3L. Now, unfortunately, I haven't been able to fully test it all out because while I have the functions written on my phone, this part down here also takes a bit of a beating as far as some changes we make, and I believe I have that written written out on my Kindle. So once I get all these updated here, I'll hop over to that. Don't worry, you'll still be on my desktop with me as I fill all this stuff out. Okay, reads a record from the file, returns it as a list. That's right, we are going to return, or we're going to have a way to read individual records, turn them immediately into lists. So here you see we turn them into strings before we write them to the file. So if we want to be able to work with them like they're records, like they're actual, you know, records with different pieces of information to them, this is what we're going to have to do. Okay, so oh, use case. That's what I forgot there. Because as I said, it returns the information as a list. We're going to want to assign the output of this function to a variable. So, in our use case, let's make sure we're including a variable here. Item's kind of our only new one here. I suppose we should include a definition for what this variable here actually stands for, or what it represents, right? Okay. Now, that's all well and good, but we still don't have a function here because we haven't wrote it yet. Helps if I can spell. Oop. We're not trying to call the function we're writing within the function as we're writing it. That would be silly. Unless we're doing recursive functions. Because, yeah, you can definitely call your function within itself. It's a bit weird, but... Sorry, this is a bit of a tangent. Some of you might recognize this as the 3n plus 1 problem, but this is also a recursive function. Basically, we're calling this function where we can give it any integer we want, and eventually it will spit out 1. Depending upon whether it's even or odd. We either take that same number, multiply it by 3 and add 1, or we divide it by 2, and we run it through the same thing. And if it's odd, we feed back in a bigger number. If it's even, we cut the number in half. Very silly little problem here, but this is an example of a recursive function. It's a function that calls itself within itself. So, whenever you hear someone talking about recursive functions, that's what they're talking about. Okay? Now, if you have a recursive function, you need an escape clause. This will always get to 1 at some point. You'll either be passing a 2 into this thing at some point, or a 4, in which case it just takes another couple iterations. It eventually gets to 1. Because what happens when you feed it 1? You get 3 times 1 is 3, plus 1 is 4. 4 is even. 4 divided by 2 is 2. 2 is even. 2 divided by 2 becomes 1. And then if you feed it 1 again, what do you get? You get 3 plus 1 is 4, which is even, and it loops forever, and ever and ever and ever. So have an escape clause. Ours is when it reaches 1, it's going to check if our input is 1, and if our input is 1, it's just going to spit out 1. And it's going to be like, no, it's a 1. You're done. You are done, sir. You're done wasting my time with this function. And it's going to quit. If it's not 1, it runs through all this stuff and eventually whittles it down to 1. It's a pretty useless function. I'm going to leave it in for fun. Maybe we'll play around with it sometime. I just commented it out. That's what that does. Like, I know you're used to seeing the triple quotes immediately following our function definitions, but when we use them elsewhere, we're basically just commenting out a chunk of code. Alright, this isn't going to return as a doc string somewhere because it's not immediately following a line defining anything. Our definition is included in our quotes. Alright, so back to this thing. And sorry about that weird little tangent, just kind of... I know that some people get thrown off by what the heck is, you know... What is recursive programming? And it sounds like a big scary term that just, you know, intimidates people. But it's really a simple concept once you're able to wrap your head around it. Okay, so what are we doing here? We're calling our read file. We're taking the entire output of that file. We are selecting the item, which was chosen here, from the index. We're ensuring that our item is in fact an integer, because it needs to be an integer in order to work as a file or as a list index. It needs to be an integer. So we ensure that it's an integer by turning it into one right here. Whether it is one or not, it will be. This might throw an error, and when we get to dealing with exceptions, we'll talk about that. For now, though, we're going to assume that that question down here in our little menu, where it asks which record, our user is smart enough to know to put in a number. Alright, so from the file output, which is a list of records, it's going to take the item that was chosen, which, as you know, we wrote it to the file as a string, but it's actually a list that's been joined together using the comma. So we're going to split it at the comma back out into a list again. That's all this is doing. And the when this all evaluates, it takes whatever this generates and spits that out. And that's why our read record, we assign that to a variable. Welcome, Dumnub. This is a Python tutorial. This is the other thing I stream occasionally when I'm not playing video games. if you're interested in learning Python, find part 1, start there. I show you how to do file manipulation with Python, how to edit the stuff in the files you create. Basically, gives you a very quick and easy tutorial on how to be a goddamn wizard. So anyway, that is our read record function. We're going to ignore our strange little block there. Alright, now, to update the record, alright, we need our doc string. We need our use case. Now, since this one doesn't have a return statement within it, and why would it? All it's going to do is write directly to the file. We don't need to return anything. All of the output is already dealt with there. Might be our longest file declaration ever. Because we're up to 4 arguments. All right. We're also coming to probably our longest documentation string ever. And boy, is it long. Oh wait, this part, do I still have that on? I do still have that on my clipboard. Yeah. There we go. Alright, but we still don't have a function yet because we still haven't wrote it. That was just our documentation. So what's our process going to be for updating records? Well, we're going to declare our file out variable. We're going to read the entire file. feed in our file directory, our file name variables. We're going to take our file output, which is the entire contents of the file. We're going to call another method of our list, since read file output's a list. This method, the pop method, takes an integer index value and it literally just deletes that item from the list. Now, we could save that item if we wanted to, but we don't need it because we're updating the file and we're updating the record by replacing it with new information. So what we're going to do is we're just going to pop it off of there. We're going to pop off the old record. And then at the new record, we're going to call another method insert. We're going to use the same index that we used to pop off the element before, because we're updating a record, so we're going to delete the old information. And in the exact same spot, we're going to input the new information. I suppose it would help if I actually declared my function with the proper variable names, huh? I did it in the doc string. I just didn't do it on the actual declaration. All right, so make sure we close our brackets there. If we don't close our brackets, that's going to give us an error. Now that we've updated the file output properly, we need to write this all back to the file. So we're going to use that file writer function that we declared earlier, or that we defined earlier. And we pass in, helps if I can type. There we go. We pass in the new and improved file out that's got the new information inserted into it. So that's how our update works. We read the file, we pop off the element we want to update, basically make room for the new information that's going there, and then we insert the new information and rewrite that exact file output as with the new changes right back out to where it was. Again, we don't need a return statement or anything because there's no return. All of our output is handled by having it written to the file. That's where our output goes. All right, and last but certainly not least, deleting a record from within a file. Oh, I can just do that. Okay. Tell the user what it's supposed to do. Well, quite frankly, it just deletes the record. specified from the file. So yeah, we want to let them know. You just delete a specific file. Very handy. Very useful little piece of kit right there. How's it going to do that? Well, all the user needs to know is you call the function, pass the file directory, pass the file name, and then you tell it what item you want to delete. No fuss, no muss, very simple, very easy to use. I did, however, mess up one thing. In our read, we used int to turn item into a number. We should follow that same protocol everywhere to ensure that when we're using those item indexes within our function, that we're making sure that they are numbers. Otherwise, we could run into errors. Now we'll just run into exceptions, which we can handle. We'll learn how to handle exceptions. Because you can write code that's smart enough to deal with that kind of problem. Alright, so how do we delete the record? We read the file. Pass those same arguments as before, file directory, file name. That'll give us that list of all the file output from within the file output, since it is a list. We just pop off the item that's at whatever the specified index for the item was, ensuring that it's a number. And then we write back out to the file exactly what it was, that same file output with the item missing. All right, and that is our create, read, update, and delete file, create, read, update, and delete record. I do have some help stuff for the file delimiter that I could enter, and for the confirmation default prompts that we've created, but we're gonna skip over that for now because we don't need to worry about that. We've seen enough entering doc strings, I think, for one day. What we want to do, though, is we want to take a look at our program loop, because, you know, if we're running this directly instead of importing it as a library, you remember before all that kitten, doggo, and kangaroo file stuff we were doing. Well, we're going to do it a little differently now because we're no longer working with a single entry per line. We're now working with multiple data points per record. Each record is its own line. All of our functions deal with lists. Whoop, I did not even... we'll come back to that. And it's just within the doc string. It'll run without that. But all of these are now taking lists as values. So, how do we loop through the input to make a list so that we can write stuff to the record? All right. Now, did we talk about the header last time? Yes, we did. I showed you how to make the header. I showed you how to make the string. So, as you know, our first record, when we read that file, that first record is going to be the header. That's always going to be 0. If we leave 0 off, it should deter our users from trying to edit the headers, which is fine. Doesn't specifically say that they can't. It just doesn't give them real clear instructions on how, which is fine, because if they edit the headers, they'd have to go through and change up the every single record in order to match that, hoping that when they write the file, or when they first create the file and they create that first set of headers, that they get it right. Okay? So what do we got here? File, enter name, file not found, create the file, canceling file creation, file not created, else file created. Then it goes into creating headers. So we've created the file. Here we have our loop. Here we're calling our create files. However, here we're joining those file headers as a string. We don't need to do that because it's already doing that here. So we're going to change that, because before we were trying to enter all of this as a single field entry, just one data field. We're now going to have multiple data fields, so we can just send that list right in as it is. We don't have to worry about the new line character. We don't have to worry about any of that. We're just sending that list of headers that we created for our file as the first record, which is perfect. Now here we are reading the entire file as before, as output, which is fine. Here we're getting our file output 0 and splitting that up as a string. How about if we just read the record? Now remember, outside of our functions, we're using file directory and file name to hold the actual values of those elements of our file path. And we can pass in a literal. That's what it is when we're not using a variable and we're just using the actual value itself. It's called using the literal for our argument for items. So up here, file directory, file name, item. We're going with item 0. Is that an integer? Absolutely. So when it goes through the read record and it does this little bit where it turns it into an integer, it's already an integer. So this will evaluate to 0. it'll take that line from the file out. It'll already split that up into the fields that it needs. So headers will be a list. We're going to get the length of headers to determine the number of fields, because that's now a list. Headers, we have the header string. We're going with a number and then a tab. We're doing a dash and a tab for our divider. This is just for decoration. Now, for range, in 0 fields, header string equals header string, which means we're taking this value here, and we're just going to add to that value the first element, then the second element, then the third element, and after each of these elements we're going to add a tab. We're stripping off any new line characters with this method here. And for each time we do that for dividers, we're doing the same thing, only we're checking the length of the element after we stripped off that new line character, if it exists, so that we're adding that many dashes, and then slapping a tab on the end of that. Then we're going to print the headers, we're going to print the divider. Now, if we get this far, and there isn't at least 2 records, we're going to say there's no records. Now, why are we going with 2 records? Well, there needs to be the headers. The headers is record number 1. Well, 0, because lists in programming start at 0. So, the second one, the second record in our file, whatever's at index number 1, because indexes start with 0, so it's 0, 1, 1 actually being the second element. That's going to be our first record. Now, if we're checking the length of our file output, and it's equal to 1, oh, this should be less than or equal to 2. No. Exclusivity. This means if it's less than 2. If it's actually 2, which is what we're hoping for, it'll print off the records. If it's only 1, that means there's only a header. We're already printing the header because we expect the header to be there if the file's created, because we make the user create a header when they create a file. So if we get to the point where we're reading a file that exists, the header should also exist, theoretically. But if there is only a header, we're going to say there's no records, because the header's not really data. Our records that will actually contain data will start at 1 instead of 0. So the second record instead of the first. So that's what we're checking here. We're going to see if there's more than a header. If it's only a header, we're going to say, hey, there's no records. If it turns out there are records, we no longer need to do this. This part where we're splitting it all up. So we're going to rewrite this a bit. Now, do we still want to use... Let's see here. So like I said, I had some of this written out. Some of this I did not have written out. Okay, so I don't have the part where I changed it using the read record, but that's what we're gonna do. We're gonna go with we're gonna use our record data variable. And we're gonna read our record into it. Use our file directory, our file name, and how are we gonna know which record we're reading? We're going to use the X from our loop. Now we're going to start at 1 instead of 0 because, again, 0 is not an actual record. It is just our headers. So we want to skip 0, we want to start at 1, and we want to go till we reach the end of file output. Now we could just, you know, keep grabbing that from file output. But we can expect file output to change a few times. So I might actually change that as well. For now, though, it should be fine. Should be. Like, I'd almost feel better doing something like, now, what does this do? Well, it takes that exact same file output that we're using up there and just sticks that right here in a length file, or a length function, and then checks the value against 2. We're also introducing errors into our code by not typing out the proper variable names. Now, what are we doing with this? Why are we doing this instead of just using the length of this? We're ensuring that when we go to check the length, we're checking the length of the actual file in its most updated form. Because between here and here, something could happen. So do we need this? No, we really don't. Alright, so displaying the records, we have our header, which we're just reading the first one. We're getting the length. And although we should just change this as well. That way we're not declaring an extra variable. We don't need an extra variable just for that. Okay. And there we're just using the headers, we're just using the divider for decoration. Here we're reading the file that we need from there, and read record returns a list now, so it's not just a single data point, it's a whole list. Which is great. That's what we want. That's what we need. That's how we're going to do it. Alright, now we want to print it, right? We want to be able to print this data, same as we did our header up here. So we're going to do the same thing, except with each one, we're going to do a record string. Going to get our X value. Add our little tab character. Now we've read our record in. Because it's a list, we can just do for each element in the list. Record string equals record string, which means we're going to take the already the record string we've already started constructing, where we added the record number and put a tab behind it. We're taking that value and we're going to add oh, that's why I'm not using Y. I almost forgot, because we have that that special new line character occasionally. We're going to want to handle that a little differently. So because we don't know at what point it's going to hit that. We just don't. So we're going to do that. After each element, we're going to add a tab, just like we did with the headers up here. We don't have to do a divider, because we're not going to do a divider for each of the records. We're only doing that for the one there. Now for each index, though, there we go. We output the string. Now, why does it keep doing that? I don't know if you've all noticed that, but every time I type a new line, it indents way up to here. I don't need it to indent that far. It should only indent up to there. But it keeps indenting up to there. So I feel like there's an unclosed loop somewhere. We're probably going to run into errors. Alright, so after it displays all the records, it's going to print out our menu. Add record, update existing record, delete existing record, etc., etc., etc. Alright, here again, we no longer need to turn this into a string. It can be a list. It'll be fine. Now we've already pulled our headers here when we're displaying the list, so we can keep using that same one. And for each item in there, we're going to have our user input a value. So this part still makes sense. When it's done, it can pass that record, same as it did before. Here again, we're using that same bit. We want to change that to update record though. And update record should just take a list. There we go. Delete record, we're using our confirm default action. And here you can see we're still having it do all the steps for our delete. We can change this. That'll take the file directory, the file name, and instead of file output, we need our user input, because our user inputted the record number that they wanted to get rid of. Now, am I worried that we're not passing a string? Or that we're not passing a number? Not really, because before we use it, we turn it into a number. We'll get an exception if it can't be converted into a number. Now, I do want to take this and turn it into a function by itself, because we use that in a couple different places. We use it when we create a record, we use it when we update a record, we even kind of use it when we create our header files. You know, it's the same thing. We declare a list, we run through this loop where we ask the user to enter information for each one of them. The only difference is when we do it for the header, we also throw in this confirm prompt in between. But we could turn that into a function. I'm not going to do that right now, though. We'll probably deal with that another time. So we have our delete record. We have our delete file. And that should confirm everything's done. So let's go ahead and save that. Now, one thing I want to do before we get too wild and crazy with this is I want to go back in. Oh, what does this mean? Is he saving all of this to the cloud? Why, yes, I am. And the reason why I'm doing that is because it's smarter. I'm going to delete the old kitten file. Alright. Hopefully there won't be any issues. There are issues. Why does it expect that there? It should not expect that there. Did I forget? I forgot a thing. Expected indent. That is the indent. But it's... I don't understand. I don't understand. Okay. Our issue starts here. Okay, since we're in the else, this needs to go in. And because this stuff is all inside that loop, we need to bring that in twice. This needs to come in twice. And because this is inside of this else, it needs to go in 3 times. There we go. Okay, yay! Figured it out. Alright, we want to create a new file. We're going to call it kittens.txt. Create the file now? Why, yes. Yes, we will. Alright, so as you see, it has created the file. Where did it create the file? It created the file in the same directory that we are using. There it is. See? It's back. You just watched me delete it. Now it's back. First header. We're gonna go with name. Continue? Yes. Next header. Color. Continue? Yes. Fluffiness. We'll call that good for now. Alright, so it loops back. It asks us, what file do we want to work within? Kittens. Whoops. No. Helps if you actually type it correctly, because up here I used kittens, plural. Here I used kitten, 1. That's a different file. They are not the same. There we go. Alright, so we're displaying our header. The record number, the name, the color, the fluffiness. All of this we just generated. Even our divider string. We just created that. As you can see, it says there's no records. Why? Because we didn't create a record, we created a header. And that is the only thing we've created. So, we need to create a new record. What are we going to name our first cat? We're going to name him Tom. What color is he? He's gray. How fluffy is he? Somewhat. Exit? No, we're not done yet. There you can see. We have our first record. Tom. He's gray. He's somewhat fluffy. Let's add some more records, because we need a bit more. We're going to go with Felix. Color. Felix is a black cat. Fluffy? Sorta. Exit? No. We're going to keep going. We're going to keep going. Add new record. Garfield. Color. Orange. All right. Now, as you can see, there are some limitations here. Because when we overtyped our name field, the tab sends us to the next column. That's okay. I'm not going to worry about that. That is not a huge issue, because all that is a display issue, and when we're done with all of this, we're not going to be displaying to the command line anyway. So we just have to remember to use smaller names. So let's update Garfield. He's record number 3. We're going to call him Gary. He's still orange. And he's still a fat cat. Alright, let's see what we got here. It's missing the record data. Just making sure I didn't mistype it somewhere. Where does it say line 233? Show my line numbers. 233. Where's 233? Update file record. Okay, so when we go to update record, what did I do here? Did I not put in the full thing? Oh, we forgot the number. We forgot the record number. There we go. Run that module. Alright, so Garfield's still screwed up. We want to update that. Record number 3. We're going to change his name to Gary. He's still going to be orange. And he's still going to be quite fat. Okay. What's going on? Must be a string, not a list. Why is it still a string? Where is this happening at? Line 23. Update record. Line 55. File. Dir. File. By the time it gets here, it should not be a list anymore. Should it? Because we're writing items in the file out list. File out is our list. Item is just an element in that list. Well, that doesn't make sense at all. That doesn't make much sense though, because that's worked everywhere else, so it's got to be a problem somewhere else here. We're doing update record, right? Update record. I wonder if it's just because we've used item, and we shouldn't use item there. Although, why are we doing it this way? That doesn't seem right. Hold on. I am pretty sure I made a change there. Okay, so we create the file, we write it. Yep. We read the file, we do that. Yep. Yep. Outputs that. Yep, that's fine. Oh no, this is the right file. Yeah. File out. File out. There we go. I mean... Okay. We no longer have our record for Garfield, so we're gonna add that back in. Okay. Now we're going to update. Because you just watched me write the information to the file, and it wrote it just fine. It's not passing a string, though. Or, it's not passing a list, it's passing a string. I'm not sure why it keeps doing that. It shouldn't do that. Because here when we add a new record, it's calling that exact same write function. Okay, so it's got to happen in our update. Update record. Okay, so it takes the record data, which should be a list. Did we not turn it into not a list? Ah, okay. Yeah. Yeah, no, we totally did that. Okay. That should fix it. It should. I think. So now up here. Where do I have that? Okay. I can change this back to item. If I can spell. Now, let's save. Let's run. Alright. Open up our kittens file. As you can see, No Garfield record again because we deleted it and then it had a problem writing it because we weren't converting it from a list into a string when we should have been, because apparently that's a thing we forgot to do. Anyway, whoops. Unfortunately, we don't give ourselves a way back, so we'll just copy this information. Hold on. Like, I know exactly what I did wrong. I took the user input and I passed it directly. What I should have done is this. Or this. Like, we'll go with that. That's better. Now, I do still have the converting it to an integer inside of the function, just in case at some point we do accidentally do that again. It hopefully won't do it again. Alright, we're going to add a new record. Call him Garfield. He's going to be orange. He's going to be fat. Alright. We're going to change record number 3. We're going to change him to Gary. He'll still be orange. And he'll still be fat. Hooray! Victory! We were able to update a record. I know, right? Super exciting. Okay, so we were able to add a record. We were able to update a record. Can we delete a record? Get rid of Gary. Gary's gone. Now that's great if we're just looking to pop off the end of our list, but can we just delete any record? Now this should only leave Felix, who's black and sort of fluffy. Although I may have screwed it up by fat finger typing. Nope, still worked. Okay. Perfect. Can we delete the file? It's gone. It works. It all works. We were able to create a file, write to the file, update what we've written to the file, remove things we've written from the file and delete the entire file. This is our CRUDdy Buddy app in basically its final form. Ladies and gentlemen, we're done with it. It does all the things. It slices, it dices, it makes 15 kinds of, little fancy radishes. However, it is still just a command line program, which a lot of people are not going to be happy with. They're not going to be thrilled. You can't take this to some corporate CEO and look at this, I've solved your inventory problem. How good are you at the command line? They're going to shoo you out of there. Now, give me a graphic user interface. Or don't come back. How much time we got? Yeah, we got about an hour and 15. New file. We're going to minimize that for now. We'll come back to it. How in the world do we do graphic user interfaces so that we don't have to keep doing things this stupid CRUDdy way with the command line? Because this is the command line. Everybody hates the command line. Nobody likes the command line because the command line is just a big black intimidating void, and it's all text, and you never know if you're going to destroy stuff or the entire universe or whatever. Maybe I'm exaggerating. Probably am. Also, like, it's not gonna let me change to the D drive, because here you can see I was at the D drive for half a second, and then all of a sudden it's back to what the command line's confusing. It's a pain in the butt. Nobody likes it. It's old. We came up with Windows because we didn't like the command line. Now, why did I just put that in a file? Why did I just type that into the thing? Bear with me. Bear with me. TK Inter stands for some stuff. I can't remember what the T and the K stand for, but Inter is short for interface. As in graphic user interface. As in graphic user interface. That's right, folks. We're finally there. All right, so the basics for designing an interface are actually not that complicated. You import your module. It uses the TK class. Also uses the window class, and as an argument to the window class, you're using the TK class. Now you can change some stuff on your little TK window. And then when you're ready to run it, when you actually want it to pop up on the screen, you run its main loop. TK is not to find my butt. There we go. Alright, so we have our window. However, as you can see, some of it didn't exactly work. That's okay. We're not doing anything with the app variable anyway. Now, probably not the most exciting thing in the world because it's really not doing much. Alright. I figured out why that didn't work. Because it didn't like my grammar. Let's get rid of that for now. We'll come back to that. There we go. As you can see, no errors this time. All sweet, sweet graphic user interface. Created ourselves a little window. I know. Super thrilling. But hold your horses, guys. It gets better. To our window, we have to add widgets. What are widgets? Well, things like buttons and checkboxes and labels and things. And then we set those. We can set various attributes to those things with, you know, like dimensions and colors and anchors and cursors and such. Now, before we get too wild and crazy with this whole graphic user interface thing, it really helps to know about objects. So, we're going to set this aside for a second. We will come back to that. Alright, I promise you. I promise, we're coming back to that. But we have our working CRUDdy Buddy app. But we don't know much about objects. So when it comes to working with a module that's very dependent on objects and methods and functions, and etc., 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 it's going to get a little confusing for us because we haven't handled that yet. So here's what we're going to do. We're going to rewrite our CRUDdy Buddy app as a CRUDdy Buddy object. Okay. You define classes or define objects the same way you define functions, or very similarly, except instead of using the def keyword, we're going to use the class keyword. So what you see up there, the class CRUDdy, that is just the definition for our CRUDdy object. The way to think about it is the class is basically the blueprint. The object is the instance of said blueprint being it's instantiated. Big word. Just means we created one. We created an instance. You know, as in a for instance. Alright, so CRUDdy. That's going to be our new class. We're going to throw some documentation in there, so if anyone happens to want to throw that into like the help thing, that'll be there. Now, inside of our class, we can define functions, we can define variables, but within the class, they're going to become methods. We're still doing exactly the same thing. It's still exactly the same thing as a function, but we call it a method now that it is part of an object. Why? Because it is that object's method of doing that action. Alright, so if you call it a function, nobody's gonna kill you. Alright, nobody's gonna send you to jail. You're not gonna be, exiled from the programming community or anything by calling it a function. But if it's a function that's part of an object, it's a method. And objects are really just collections of functions and properties. Properties are just variables. Just variables. Alright, and you're going to see that here in a minute. You know how we're using this file dir and file name like everywhere? Those are properties of our CRUDdy object. Or at least they will be. Now when you're defining or declaring your class, in these parentheses you can put in whatever object this class extends. And that's a whole thing on inheritance and whatnot. If you make an object, you can actually make an object based on another object you've just made changes to. That's all that means. So say we had made some other object, but we wanted to add some more functionality, but not, to the original object, to a new object based on the original object, we would put that object here. That previous object that we made. We'd put that here, and then all of the stuff we did creating my object would already be available, and the only thing we have to put in the definition for this class would be the changes we wanted to make. Since we're starting with a brand new object, we're going to define the first function, which is the init function. That starts with underscore, init, underscore, and then your brackets. This is the function that is called every time we create one of these. So if we're going to create a CRUDdy object, we're going to create an instance of the CRUDdy object in our code. And I'll show you how to do that later after we define our CRUDdy object. You have to create the object, or you have to define the class before you can create the object. You have to write the blueprint before you can build the house. This is the blueprint. When we instantiate it, that'll be the house. We're not extending any other previously defined object. This is a whole new object we're making. This is the first method within our object. First keyword you always want to give your the first argument, first parameter in every function you define within your object, every method you define within your object, is going to start with self, because you are passing the object to its own methods. Alright, that might be a little confusing, but just don't forget to put self here as the first parameter in your functions within your objects. If you leave it out, this is automatically passed to those functions anyway. So if you leave that out, it's gonna come back with an error saying that you're trying to call your function with too many arguments, because they're automatically going to try to pass self. And what is self? Self is the object itself. Now, we're going to go ahead and start off declaring our function, and we're going to pass the file directory and the file name. Because when we think of the CRUDdy object, we want to think of the object as a representation of the file itself. Alright, so we're going to pass the directory, we're going to pass the name. Alright. These are properties that we are setting within our CRUDdy object. They're just variables. We're using the object notation self, which is that first object that's being passed to our method. Whether we want it to be or not, we have to include it. Whether we're going to use it or not, we're going to include it. But because we want to be able to set this up as an object, and we're going to first start with our initiation function, assigning certain values to certain properties, this actually all works out. Alright? We have no argument that they want to include self, because we're going to take and create some properties of the object itself. And the first one we're doing is the file directory. When we create our CRUDdy object, first thing we are going to do is we are going to tell it what directory it resides in. And the second thing we're going to do is tell it what name it has, so that it can find the object that it is supposed to be representing. Alright. For now, that's good. We don't need to worry about anything else within our init method. But we want to start pulling some of these. Into our object. Alright, so by making this a function that's being declared within the code block following this, we've just made this a function or a method of our CRUDdy object. Now, we no longer need these two arguments here. File dir and file name. Nope. We're going to use the properties we declared instead. We're also going to pull in that file delimiter as part of our CRUDdy object, just as kind of a nice little utility function. So anyway, we've already managed to clear up some of our code and make creating a file simple. When we create a CRUDdy object, all we need to do to actually create the file itself on the file system is run the create file method. And because the object already knows the directory and the name, it should just be able to do that. Same here. We no longer need to worry about the object needing to know where that file is, because it already knows. We defined it once. It's now a property of the object, and since these methods are also part of the object, they'll be able to do all of the stuff we want it to do. No problem. Now, we don't need to make this a part of itself, but we could if we wanted to store the contents of the file long term. We don't. We're okay with the file contents being stored in the file, so we don't need to do that. And what you'll see here is this also simplifies a lot of our documentation as well. Since we're able to get rid of the directory and name usage. Now you might be noticing in my use cases I'm not including the self. Because really we don't need to. Although we should include our object here. Now, we're not going to declare any kind of documentation for our init because that's not a function or a method that the user needs to be responsible for. CRUDdy, when it declares itself, when it creates an instance of itself, will call that function. The user won't be calling that function. So we'll be putting just the standard documentation for our CRUDdy app here, and we'll flesh that out a little more later. For now, though, want to make sure everything is properly indented because we're adding all of this to our function, or to our class. Alright. So, creating file, reading a file. Updating a file. Or using the right file. Alright, now we don't want to forget to change these, because these are no longer... These are no longer correct, so we need to make sure we're updating those. File out can still be file out. We can get rid of this because we solved that problem, and that was just to write some output so that I could see what was going on. I want to make sure all of my blank lines are at least indented to the proper... Whoop. the proper place. Alright. Here we're going to run into some stuff. Alright. Giving a once-over real quick on all the stuff we've done. Okay, so create record. We're now using a method of our object. We don't need those. Record data is still an argument being passed. Alright. So what's the difference here? As you remember, we wrote read file, and now we've made it a method of our CRUDdy object. And since this create record is also a method within our CRUDdy object, and we're passing our CRUDdy object itself to our create record, we have access to all of the methods of our CRUDdy object by referencing this self variable. Which means this method is the read file that we wrote previously. This write file, same thing. That's now the method that we wrote previously as part of our CRUDdy object. Alright, let's see if we need anything here. We need to change this to self. Need to tag ourself there. We can remove that. Alright, I'm going to take this out. I'm going to play around with that later. But it doesn't need to continue to live in our little program here. All right. Want to make sure we're not forgetting to update anything so that it's referencing the properties and internal functions of this object we're making. We also want to make sure we're updating everything in our documentation as we go along as well. But our code looks a lot cleaner now that we're not having to reference the file directory and file name every single time we're doing an operation. Why? Because it's already implied with the self, and the self is automatically passed. We don't have to, when we call these, as you can see, I'm not putting anything in for self. It already knows what it is, so we don't have to. It's automatically passed in. Oh. Good enough. Now, this might all still seem rather clear as mud, because I haven't shown any examples or anything. We're still updating our file here, and I'm hoping to have it updated in time to demonstrate it for you so that you can see it does things. And it does things cleaner and neater. It's not quite so messy. But look at this. When this works, we'll declare a CRUDdy object. When we declare the CRUDdy object, we'll pass in the file directory and the file name, and that is the only time we'll ever need to tell it what directory and name the file it's referencing is. Only time. If we want to create the file, we'll just tell CRUDdy to create the file, and it'll do so. If we want to read the file, we don't have to pass in any arguments or anything. It just knows which file to read because it's the file that it is in reference to when it was created. And it'll spit out that information to whatever variable we want to assign it to. We're not making this a part of the CRUDdy object because we may not necessarily want to take the output of the file and reassign it to an attribute or a property of the file. We might want to just use that information somewhere else. And that's fine. Totally legit. We're able to do that. And same with our being able to write to a file. Like, we could make it so that we assign the contents of the file to a property within the CRUDdy object. And whenever that changes, it runs a function to output that property in its entirety to the file as file output. This is just easier. We're just going to do it this way. It's fine. When we go to delete a file, the only file that it's able to delete is itself. Kind of a nice little safety measure. It can't just delete any file, it can only delete the file that was referenced when it was created. So that's handy. A little bit of a safety control on our delete file. We can't delete any system files or anything that way. Very nice, very handy. When we create a record, we'll know exactly where that record's got to go. We don't have to keep telling it which file, because it already knows. That's already happening. When it reads a record, we only have to ask for, or we only have to tell it which record we want. We don't need to tell it the directory to look in. We don't need to tell it the file to look in. Because again, that's all told to the object when the object's created. And as long as the object exists, we can keep referencing it. When we update a record, again, we just have to tell it which one and what the new information will be. We don't have to tell it, we don't have to tell it what file path to go looking for, what file name we want to add this record to. All that's already part of our object. Deleting a record, we'd only have to pass the name of the record that we want to delete. Now I'm just using CRUDdy as an example object name. We'll be able to call these files whatever we want, as you'll see in a bit. Now this one we didn't used to have to pass anything. Now we are going to pass self, but that's because every function That is a part of our class. We'll have to have that. All right. We're not going to add our confirmed default actions, action prompts, as part of our object declaration, as part of our class blueprint. We may add them to something else later, but they are not part of our CRUDdy Buddy object. Just to be clear. Alright, so we still want to start this off by asking, what the current working directory, or by getting the current working directory, and passing that into file directory. Now here, at the start of our program loop, I'll go ahead and call this file object. Now, when we declare our CRUDdy Buddy object, we are going to be calling this. So the arguments we're going to pass in are the directory and the file name. So where are we at here? We already know the directory. For the file name, I'm just going to go ahead and put that right there. Going to go ahead and make that a part of our object creation. That shouldn't be terribly new. We've done things like that before, like where we have our if statement calling for our custom prompt. Like this will call this function before it evaluates the condition. So that's the same thing that's going on here. It'll call this before it creates our CRUDdy Buddy object. But upon doing so, upon entering a name for our file, we will have created a CRUDdy Buddy object. And we will have assigned that CRUDdy Buddy object to file obj as our variable. That's our label for this object that was declared using this class. Now we have a couple of properties here that we can use: the directory and the file name. Here we use file directory. We're going to use the file delimiter method that is now a part of our CRUDdy Buddy object. That is stored in our file obj variable. There we go. And this line will still perform that same check to determine if the file exists. If it does, great. If it doesn't, it'll say it doesn't exist, and it'll ask us if we want to create it. And you remember, our create file no longer needs to be passed those. Now I keep using this label at the front of all of our functions that we wrote earlier, and that's because that's how we reference our file object now. And I can also remove the arguments from before that we no longer need. Which makes some of this look a lot cleaner. A lot cleaner. See, this means the same thing that it did before I changed it. Except now, this function is part of the file object that we created, the CRUDdy class, and we no longer need to pass it the file directory and file name like we used to before. We can just pass the index for the record that we're looking for. Now, a lot of people like to make a big deal out of class and object and make it all super confusing. But really, all an object is a collection of properties which define the state of the object. And I don't mean like, state as in, Minnesota, South Dakota, Texas, California, New York. No. State as in, like, what condition is it in? And how do you know? Well, you reference the various properties. What state is our CRUDdy object in? That'll be the file directory and the file path. We'll tell you what state it is. And the functions within our class definition are the methods that it is able to use. So it can interact with the data that it holds, the various properties, as well as data outside of itself. Like this is just what that object does. If you wanted to make a car object, you would make a method or a function that would tell it to turn on. That would tell it to, accelerate, brake, turn left, turn right. Alright, so where was I here? I was down here a bit of the ways, I'm pretty sure. Alright, so. I mean, same thing here with the length, making sure that when we read the file, the list of records is at least 2 long. Otherwise, it'll say no records, because if it's only 1, that's just the headers. That hasn't changed. Like, the behavior of our functions is still the same. The arguments we have to pass to it in order to allow it to do what it was doing before is now different. And the way we reference or call our methods is slightly different. That's it. That is the only difference between what we already did and what we're doing now. And you can literally watch me make that happen right before your eyes, right here. And it sure is looking a lot cleaner, too. It really is. Oh, not self. We only refer to it as self when it's inside of the declaration for the class. Up here where we're writing the class and we're doing all of the functions, all of the methods of the class, that's the only time we're using self. Down here where we actually created one of our objects, we refer to it with this label instead of self. Now I lost my place again. I do that a lot. I do that a lot. Ah, here we go. And you can name your file object whatever you want. I just went with file obj because it's short for file object. It's easy. And I went with camel case because, as you've seen before, my simpler variables, my simpler labels have been words spaced out with an underscore. Reason why I'm going with camel case is because file obj references an object, and I prefer to reserve my my labels for objects to be what's called camel case. Lowercase first word and then capitalize the first letter of each additional word in your label. That's all camel case is. Why do I do that? Because then I know, looking at it, oh, that's an object. Probably an object I defined myself. Oh, wait. Here I'm messing with all that. I don't need to do any of that. Okay. I think that's all of it. Save it. Run that module. Welcome to CRUDdy, buddy. File not found. Create it now? Why, sure. Kittens is back. First header. Name. Yes. Color again. Yes. Fluffiness. We're done. All right. No records. Let's add a new record. Tom. Gray. Slightly fluffy. Add another one. Apparently, I screwed that up. Okay, we're back. I fat finger keyed earlier, which caused this error, which then caused this error. So I had to fix the file. Be careful how you type. Is that something we could probably fix with some better problem solving and whatnot? Absolutely. Absolutely. That is my fault. I screwed that up. I could probably make it so that that's no longer a problem with some more problem solving, but I just wanted to show you how object-oriented programming works. Alright, so now we need to delete a record, because we updated a record. Sort of. Let's try it again, though. Update a record. 1. Tom. Gray. Slightly. It's not adding the new line, though. So what was that? The update... Let's see here. In our update record, are we adding a new line? No, we're not. That's why we're having so much trouble with that. Let's open this up again. Add our new line. All right. Tom is now Tim. He's still gray. Slightly fluffy. It still didn't do it though. That's because I didn't exit the program. I have to rerun the module. There we go. Put that in ourselves. Okay. Updates. Tim is apparently now Tom. Still gray. Still slightly fluffy. Now. Hooray! It works! Okay. So, updating still works. Deleting? Does deleting work? You know what? We're going to get rid of Tom. That record's caused us enough trouble today. Yes. Now we don't need to exit. And as you can see, the record is gone. Can we delete the file? Deleting kittens txt from the thing, are you sure? Yes. It's gone. It's like magic. Ah? Ah? Alright. I'm gonna say that's a good place to stop. We turned our CRUDdy buddy library of functions into a CRUDdy buddy class. Demonstrated how to get an object out of that. How to get an object out of our class definition. And then all the ways we can use that. And all the ways that simplifies our program. I mean, it probably didn't make a whole huge amount of difference, but like it does make it a little bit easier to read our code. It does simplify things a little bit. And later on, when we're doing, when we import this library, you'll see more of that. And we're going to import this library with a graphic user interface library, and we're going to try to create an actual sort of an Excel spreadsheet-esque kind of program. Like, don't get too carried away though here. We're not going to be that, like, we're not going to be making the new Excel, okay? Not even close. But it will have a graphic user interface, so you'll be able to enter information as you need it, without having to go into the command prompt, without having to do all that stuff. And we're going to try to set up a way in which we'll be able to edit the different fields without having to toggle through all of them. So that should be helpful as well. I hope you've enjoyed this tutorial, this part of the tutorial. I know, again, I pass over some very complicated concepts without so much as a second thought, without a whole lot of explainer. But the reason for that is because we're not going for professional here. We're going for, can you pull this off in your own home, on your phone, when you need to because you want to. Not because you're getting paid to do it, but just because say you want to make a game. Finally. You know, you have this idea for this really cool game. Well, you could actually start writing some of it. You could actually start creating some of your game. Now, I know this doesn't seem like it'd lend well to game creation, but what we have here is a utility that we can use to create a lot of back-end resources. For example, if you were to take a look at an RPG, like Final Fantasy, every object in that game, every pickup, every person you talk to, every enemy you fight, every weapon you collect, every piece of armor you can find in a game like that is probably stored in a file. And that file is probably set up like a spreadsheet that contains a whole list of all the different swords, all the different monsters, all the different NPCs, what their hit points are, what their magic levels are, what kind of loot tables they may have. All of that stuff is contained in files similar to what we've been creating with our CRUDdy Buddy app. Our kittens being Felix, black in color and a little fluffy. Having a file that contains that information for us, I could later create a program that pulls in Felix, draws a little black cat that's slightly fluffy. I mean, maybe not the greatest example, but you get where we're going. We've already created quite a bit. Now, we just need to create a graphic interface that can work with these files. Once we've done that, we have ourselves not only the capability of making Excel programs and form programs, but we'll also have a basic understanding of object-oriented programming using pre-constructed libraries. Because after we figure out how to make Windows and be able to make a form in Windows that can help us create these files, I'm thinking Pygame would be a good one to check out. Pygame is it's a library for making retro games. It's not the latest graphics engine. It's not, it's not Unity. It's not the Unreal Engine. It's nothing like that. Not even close. But you can make very simple games. You can make simple 8-bit games quite easily. You can make slightly more complicated games too if you get really good at it. I mean, sure, you are going to be a little bit limited on what you're able to do with Pygame, but you'll be able to make games. And so far we have games with a back end where we can create data files, where we can create resource files for our program. Another thing I'd like to cover in a future episode or session of our little coding project here is sockets. We're going to play around with network connections. So we'll be able to take our game and add some online functionality to them. Now, that will be a little bit different, because we're either going to have to come up with a server client sort of thing, or we're going to have to do peer-to-peer. Each of those is going to come with its own little hurdles to try to clear, but we'll be able to do that with a little bit of network know-how, and we're going to look at the sockets module when we get there. That's how Python talks to the internet. So be sure to hit that follow button if you want to find out more about all of that in upcoming episodes. We're about done here. Where is my mouse? There's my mouse. Alright. So, thanks for joining me. Thanks for following along with this tutorial. Be sure to continue to follow along to find out how to make even cooler stuff. But now that we know object-oriented programming a little bit, we just dipped our toe in, we know enough to create an object, to define an object, to keep our properties for objects together, and the methods that they have for interacting with those properties and other things together. Next time we'll be able to get into graphic user interfaces, and we'll be able to do some object-oriented development with that. It's a lot easier with the object-oriented mindset. And from there, we're just going to keep growing this thing and see what we can make. At some point, we just might develop a game that we can play, and invite our friends to play with us online. Who knows? We'll see. Follow to be followed back, and to find out when I'm alive. Join the Discord. The link's there in the on your screen right now. And feel free to check out my website. I haven't done a whole lot with it, just written a couple of real brief articles. I should write more, and I will when I have time. But thanks, and you have yourself a great day.